Welcome to this tutorial on Witness 3D and Witness 14. This tutorial covers the use of different layers in Witness to offset displays in 3D and includes the setting of extrusions as well to extrude from lines, rectangles and ellipses to augment the display. The first model we're going to look at is in the sample models directory. If I open up quick3d.mod, we can see this layout here with the lines drawn around the outside, which we're going to extrude to make walls, and it's a series of conveyors, machines, tracks and vehicles and the like. So if we do a quick 3D view of that model, we see that we get a three-dimensional view of the 2D schematic as we explained in the basic tutorial, but we have different layers, we have different floors, and we have different walls at different materials and different machines at different heights on the different floors, different levels of the model. So how is all this set up? Well, let's go back to the 2D schematic and let me just make it a little bit larger so we can see that in a little bit more detail. Let's zoom in on this particular schematic. The first thing is to use different layers for different heights, and layers can also be used for offsets in other directions, but height is the most normal use of different layers. So this particular machine here, the process loader machine, if we just look for on the toolbar here, let me just dock it in a different position so that we can see that more clearly. We'll see that machine icon is drawn on the simulation layer. Whereas if I look at the machines which are on the mezzanine floor, on the higher floor in the 3D, we'll see that they are drawn on layer 6. Now, where are these layers actually set up and defined? They're set up from the View menu. There is a Layers dialog that we can go to, and this is the structure of the Layers dialog. In Witness 2D displays, you can have any number of layers that you wish to have defined. You can add more and you can remove layers. Here we have the basic kind of 9 layers that are set up as standard when you open up any startup model, but here they've been adjusted slightly for this particular model in order to represent different floors. So for example, if we look at the simulation layer, then I'll just click the one below it so we can read the figures. VRX, VRY and VRZ are 0. So that means that they will be drawn at exactly the same positions as in the 2D display, at a height of 0 as well. The Y direction here is the height. And they're on floor number 1. If we look at the bottom of the dialog, we can see that floor number 1 is at a height of 0 from the base level. Now if we look at layer 6 on which the other machines were drawn, this also is at an offset of 0, 0, 0, but it is defined on floor 2. And if we look at the bottom here, floor 2 is defined at a level 3 distance units above the basic floor level. So because we're using a second floor, when we do a quick 3D, we will get another floor drawn at that level, and any objects on that floor, on that layer, will be drawn at that level. So we are going to get the machines just coming out of that, these treatment machines drawn on layer 6, they will be drawn in 3D at a level of 3 distance units above the base floor level on a separate floor defined by that. Now we've seen before in earlier tutorials that items such as conveyors can actually move between different layers and have different changes in height along their length. If we look at the paths toolbar, then for any conveyor we can pick that information, and we can see that this conveyor does indeed go from a height of 0 up 3 distance units at that particular point in that straight, and goes up to the same level as we picked for floor 2. So this conveyor will feed into the treatment machines at that exact same level. So when we do the quick 3D, that's exactly what we see. We see our floor here drawn at a level of 3 distance units, and we see that conveyor actually going along at the basic floor level and then up the 3 distance units to tie in with delivery to the machines on this second floor. Let's now return to the 2D schematic again and look at the way in which the extrusions have been done from these lines which are drawn around the outside. Here we have little line segments drawn on layer 5, and at the mezzanine layer we have different line segments drawn on layer 6. Now it's a little bit difficult to see all that because some of the 5s and 6s line segments are drawn on top of each other, and you would have to draw those separately and then bring them together on the display. But some are drawn on level 5 and some are drawn layer 5 and some are drawn on layer 6. So if we look at the layers dialog again, we can see layer 5 and layer 6 are both ticked as to be extruded. Is extruded. Each extrusion has a width for the thickness of the wall and the height of the extrusion, which will start from a height of the floor level up that particular distance. So the height will be 2 distance units of each of the walls here, and then we apply to each of those extrusions in this box at the end a pull down list of which pattern do you wish to apply, or which colour do you wish to apply to the walls. Here we have a brick pattern, a repeating pattern, but equally well you could just pick a colour, or you could pick a more detailed image. You could have lots of paintings or full kind of pictures included on the walls using this method. It's also possible, not impossible, it's also possible to import different pictures from a JPEG format, and we'll have a look at that a little bit later in this tutorial. So let's just go back to set that to bricks again. So we have that layer being extruded in the bricks format and the other layer being extruded in the simple line format. These are both examples of images which are supplied with the base set of Witness images that you get in the startup model in Witness. So because they're extruded to a height of 2 distance units, we know floor 1 here is at the height of 3 distance units, and that seems to tie in very well with what we see here. We see the one layer extruded up to a height of 2, then a gap of 1 meter to the next floor, and then another height of 2 meters in the different texture that's drawn. You can also extrude rectangles and ellipses. Ellipses can be, of course, a good way of doing columns, and they will extrude in a solid form with capped ends. Let's have a look at a different model. In this model we have 2 floors of different machines that we want to look at, and they're joined and linked to by a single conveyor here. Conveyor 001. Now these machines here are drawn on the simulation layer. These machines here are drawn on a layer that's entitled floor plus 4 meters. And if we go to our layers dialog, we can see this is the setup. So the simulation layer is the normal layer with an offset of 0, 0, 0. The floor plus 4 meters, now in this case we've done it on floor 1, so we're not going to get another floor drawn. Equally well we could have had another floor drawn here, but we haven't. But we said that the displays for these machines are going to be 4 meters above, or 4 distance units above in the Y direction. But we're also saying that the Z direction is offset by -10. Now what do we mean by that? We mean that the Z direction in Witness 2D goes down the screen, And with the coordinate units that we're using here, we can see that this point here of this wall is at unit about 5, 10. If we go down to here, it's about 5, 20. So we have an off shift of 10 units. What we want to do in 3D is to put one bank of machines above the other bank of machines, and the conveyor then will link the two. So let's again have a look at the paths toolbar and look at the information on the conveyor. And here we can see that the conveyor goes up 3 meters, up another meter, up another 4 meters, so that's a height of 8 meters in total, and then comes down 1 and comes down another 3, so comes down just 4 meters, goes up 8, comes down 4, so we'll end up at a position 4 meters above where it started, which will be where the second floor will be based on the offset on the layers dialog. You'll notice for any conveyor we also have the option down here at the bottom left of setting a starting height. So when we actually build this in 3D, what do we get? Let's have a look. This is what we get. We get a model whereby parts here are travelling along out of one floor, up and round and over and then down into the second floor using the single conveyor. And one bank of machines here is directly above another bank of machines. Now sometimes you'll want to do this with the different floors. You won't want to have a second floor because it would obscure the view of the lower bank of machines on the lower floor. But sometimes you'll want to put in proper floors and be able to see that happening as well. Let's have a look at a different model of this same situation done slightly differently. So here we have, we want to see now the conveyors coming into their correct levels rather than have them as before where they came into the same level from all intents and purposes, and we couldn't see what was happening on the conveyor on the lower level when it was below the upper level. So here we've split the conveyor into two. The conveyor 1 will push to the second conveyor. We have all the different lengths and speeds the same, so that will make everything work exactly the same as it did before. But now what we can do is we can draw this conveyor at the level floor plus 4 meters. This is the one feeding into the upper level. I've slightly swapped it round from the other model. I think the upper level now is above the lower level on the 2D display, and I had it the other way around in the other, but that was because it fitted the conveyor displays better. So this conveyor now is going to, this is the upper floor, and if we look at the layers dialog now, we can see that we have a positive 10 now difference for that floor plus 4 meter layer. We still have 4 meters up in the Y direction, but the Z direction, Z difference from the normal is 10 distance units. So again, that's a distance different. That's the distance that we've drawn it to scale, looking at the units here, from approximately here 10 to approximately here, which is 20 distance units. So because this is now starting at this particular height, if we look at the paths toolbar again, we can see our starting height now is at 4, and all we are going to do is to go down that 4 to that level. Now that's because our basic height for that level is already up at the 4 meter level based on the layers dialog setting. So all we've got to do is come down the 4 meters to that layer. The other half of the conveyor, if we look at the paths toolbar again and the information, this goes up the full 8 from the basic floor height, starting at height 0. And if we do a quick 3D on this model, we get exactly the same result as we had before. The two conveyors join seamlessly at this point, and one of them feeds up to layer 8, and then the other one takes 8 meters above, and the other one feeds down from 4 meters above the layer on which it's drawn, which is on the second kind of level, which is at an offset of 4 meters above. So it makes it very flexible. It means that your 2D layout doesn't have to be compromised to effect a 3D stacked layout looking properly. And that makes it much clearer to have that in 2D and 3D. Now we can see some complicated shadows appearing down here. Don't forget that just click in the view, turn and press Ctrl S, and those shadows can disappear. You'll also notice we have a plain dark grey floor here. That option is entirely up to you. You set that in the Customize Quick 3D options. Here I've got a checkerboard display of dark grey with dark grey, which gives a uniform dark grey appearance. This dialog gives me the option to just talk about one extra thing, and this is the definition of what we term in this dialog a ceiling, a height of 4. This is only for use with conveyors where things hang underneath, so power and free type conveyors, electric monorails, the like. Those in a model will always be offset off the floor at that particular height above whichever layer they are drawn on. So that's just for use where things are appearing underneath, hanging underneath conveyors. In 3D, you'll also, the default options are that parts which are on a conveyor going at an angle will always be angled, but of course if things are hanging beneath and suspended from a conveyor underneath that kind of geometry, then they will hang vertically from that particular point of the conveyor. Let's look at a few more examples of extrusions. So if we go back to the sample models directory and open up office movement.mod, we can see here in the layers dialog that there are a lot of different patterns selected, a lot of different layers used. Here we've added to the basic layers. We now have 12 different, 13 in fact, if we count the simulation layer. By the way, simulation objects do not have to be on the simulation layer. Often we do put them all on the same layer, but that is not a restriction. Simulation objects can appear on whichever layers you wish them to be on. Now here we can see that we have a single floor. We have one layer which is not shown in 3D, and that's perfectly possible as well to have 2D labels or things or 2D objects that you don't want to be shown in 3D. But for the ones which are ticked here as extruded, that will be the majority of the lines and the rectangles and the circles that we have in the display that we're showing here. So if we do a quick 3D of this model, and this is something you can do with your version of Witness as well, this is the display that we see. We see, you might again have different color floors and come up in the standard model because that's something which you change yourself, and it's changed in the registry and held in the registry, the different floor colors that you have with different models. But here we see the cream walls here on the outside, the patterned walls inside, the I don't know what they are, bookcases or whatever along, or tables along the side here, which are just extrusions of rectangles. And then the tables over in this particular area, this little cafeteria area, these are two extrusions of ellipses to different heights from different levels. One a big circle and one a much smaller circle for the central support. When you extrude a line segment and apply a pattern to it, then the pattern will spread across the whole of that segment. Maybe it'll be clearer if I go down this end, where we can see that here we have the pattern quite well spread out on this particular wall segment. Here it's much more compacted into a smaller horizontal stretch. So if you want to get regular kind of wallpaper type effects, then it's important to draw a line segments of a regimented and similar width along the whole length. Let's have a look at taking a new picture into the different extrusions. So if I pick the simple pattern of one of the main wallpapers here, which here we're extruding again this layer on floor 1, a width of 0.01 and a height of 2 distance units, we can use this import button here. And if I go to my desktop, then I have a picture directory, and I'll pick the picture of the motorbike. So let's pick that, OK that, quick 3D again, and lo and behold we have lots and lots of different pictures of motorbikes, well, the same picture of motorbike repeated over and over again. The quality, if the quality of the picture is good, the quality of the picture on the extrusion will be good. So here we have a very, very attractive set of pictures of that motorbike as our wallpaper in this example. Any JPEG image that you take in can be used for this purpose. Something else that's well worth noting in this is this hole that's been created in this wall, and that's done by extruding 3 different layers to 3 different heights, and then drawing a line where there's a gap in the line of that on that middle layer. So if we go to the layers dialog, we have 3 layers here, layers 8, 9 and 10, and these are all drawn in cream. That's just a cream color, it's just a small, that's actually one on the standard dialog, but if you want any other color, just save a small section of that base color as a JPEG in any paint program, and you can bring that color in and just use the basic color. We give you about 20 different colors to use as standard images, but the first layer, bottom layer here extruded to 0.5, the middle layer extruded to a height of 1, the top layer extruded to a height of 0.5, but these are offset as well. So the middle layer is offset up 0.5, the top layer is offset up 1.5. So that creates that 3 multi-layered effect to create this window effect here. And that could be used to do door architraves and a whole load of other different examples. I think I might have another example here of this same model where I've done a little bit more detail on that. If I just quick 3D this particular model, then we can see, if we zoom in, I've put a lot more windows around the outside of the facility that we can look into using this same method. I've done the doors in a different material so that the doors come down to a certain level but are angled away, and then we can do the tops of the doors, and this could all be made to look as realistic as you want to make it, and an easy way of creating a compelling environment. Here's another very simple model. I've just put in a couple of machines to create a certain floor area, but I've drawn a single, actually there are 2 lines drawn there, the same length but on top of each other, and one is drawn on layer floor plus 1 meter, which I've actually put at 0.5 meters above the floor level, and the other one is drawn at the floor level and is a very short 0.5 meters high. The length of the line will be dictated, of course, by how long it is drawn in this particular display, and we can see that it's actually drawn 15 to 25, which is a length of 10 meters. So that bottom extrusion will be very small. When we quick 3D this particular one, we can see that I've put in here a chart that I've just went and copied out of Wikipedia, just to show you how beautifully clear some of these graphics can be. Here is a diagram of the citric acid cycle. Totally unrelated to any model I've ever done, but I just picked it as a first example of an attractive chart that I found on Wikipedia. And the bottom layer that I've put in here was so that I could actually put the reference for that and give the acknowledgement to where it came from. So all I did with that was I cut and pasted the words into a text box in PowerPoint, saved those as a JPEG file, and then I applied it to an extrusion at the bottom here. So we give the proper credit where credit's due to the authors of this beautiful diagram. So you could have lots and lots of explanatory information on the walls. It comes through on both sides. It's not the wrong way around on the other side. If you do an extrusion that's much thicker, maybe we should just try that. Let's just do an extrusion that's much thicker. So instead of 0. We'll leave, maybe make them both a width of 5 instead. What we will see if we do a quick 3D, and the viewpoint will stay here the same, is we will now get a cube with that drawn on, well, a rectangular cuboid, but of course the image is applied equally across the thing, so it's a little bit restricted on the sides there, and it's a little bit restricted on the top, although it doesn't look too bad at all, to be honest. It still looks quite nice because it's not wildly out of proportion. And we will have the same on the bottom box, but we're not going to be able to see that because the top box is in the way for looking at the top of that bottom box. So that's what you get with a rectangle, a line, when you make it a much thicker extrusion. So that ends this brief tutorial about use of different layers in Witness 3D. The use to offset different elements at different heights on different floors, and also to do extrusions and bring your own images to augment the model displays that you have. Thanks for listening.